Hi everyone and welcome back. Today we're going to see trigonometry. Find the values of a trigonometric function of an acute angle. If we have a right triangle with acute angle, next to this angle theta, the side A, it will be the adjacent. Remember, adjacent to theta, it means next to theta. The biggest side, the longest side, is hypotenuse. It will be C. And the opposite side, if I trace a line from this vertex and I hit the opposite side, opposite to theta. You see, it's opposite to theta, adjacent to theta, and hypotenuse. As we saw before, sine of theta is opposite divided by hypotenuse, or in this case, B over C. Cosine of theta, adjacent divided by hypotenuse, or A divided by C, and tangent of theta is opposite divided by adjacent, or B divided by A. The other three trigonometric functions are cosecant. Cosecant of theta is hypotenuse divided by opposite. Do you see the relationship between sine and cosecant? They're basically the same, but they are upside down. Hypotenuse divided by opposite, or C over B. Secant of theta, hypotenuse divided by adjacent, is the same relationship with the cosine. They are the same, but they are flipped. And now, cotangent of theta, adjacent divided by opposite. Again, they are exactly the same relationship as cotangent of theta. We can't say they are inverse function of this one, because inverse function of tangent is another thing, and the same for cosine and sine. But we can say they have this relationship, they are the same function, but they're flipped. Instead of be opposite, it's going to be adjacent, and instead of be adjacent, it's going to be opposite. Let's find the values of the trigonometric functions. Okay, sine is opposite divided by hypotenuse. Then we need to focus where is theta, and what is 3 and what is 5. This side is opposite because if I draw a line from here, the side that I'm going to hit is the opposite side. Then I know adjacent side and I know hypotenuse, but sine is opposite divided by hypotenuse. How can I find the opposite side? Well, I can use Pythagoras. Remember, Pythagoras is c squared, or hypotenuse squared, equals to, let's say c is equals to 5, and 3 is equals to a. A squared plus b squared. Because I want to find opposite, I want to isolate for b. Then c squared minus a squared is equals to b squared. 5 squared minus 9 minus 3 squared is equals to b squared. Now it's 25 minus 9 equals to b squared. 25 minus 9 is 16 equals to b squared. How to cancel the second power? We can use square root on both sides, and the square root of 16 is 4, and 4 equals to b. Well, we have two possible answers, positive or negative, but we are talking about distance. Then we're going to use the positive signs of 4. Okay, now we know this side is 4. How can we fill this? It's opposite divided by hypotenuse, then it's 4 over 5. What about cosine? Adjacent divided by hypotenuse. Adjacent, which is 3 over 5, and tangent, which is opposite divided by adjacent. Then it's going to be 4 over 3. What about cosecant? Hypotenuse divided by opposite. Hypotenuse divided by opposite is 5 over 4. Hypotenuse divided by adjacent is secant. Pi over 3. And the last one is cotangent is 3 over 4. Okay, as you can see, we can find a relationship between those trigonometric functions. In those relationships, we're going to call them fundamental identities. First of all, we're going to have the reciprocal identities, which is cosecant is going to be equals to 1 divided by sine. Secant is going to be equals to 1 divided by cosine, and cotangent is equals to 1 divided by tangent. Other fundamental identity is the quotient identities. Tangent of theta is equals to sine of theta divided by cosine of theta, and cotangent of theta is equals to cosine of theta divided by sine of theta. Now let's going to do an exercise. Find the value of the remaining trigonometric functions given sine of theta and cosine of theta. Given sine of theta is equals to square root of 5 divided by 5, and cosine of theta is equals to 2 square root of 5 divided by 5. Find the value of each of the 4 remaining trigonometric functions of theta. Then, what do we know? We know sine of theta and cosine of theta. We're going to use the fundamental identities. It's not important where I'm going to start. You can start with secant, you can start with cosecant, but I'm going to start with tangent. Tangent of theta is equals to sine divided by cosine of theta. Why? Because I already know sine and I already know cosine. Well, then I can say tangent of theta is equals to sine of theta is square root of 5 divided by 5. And cosine of theta is 2 square root of 5 divided by 5. How can we solve this type of division? Well, we're going to multiply square root of 5 times 5 and 5 times 2 square root of 5. 5 times square root of 5 and 5 times 2 times the square root of 5. Simplifying my expression, I can divide 5 divided by 5 is 1, and square root of 5 divided by square root of 5 is 1, and my final answer is 1 over 2. I can say tangent of theta is equals to 1 over 2. Now, we know cosecant of theta is equals to 1 over sine of theta. So it's one of the fundamental identities. And we know sine of theta is square root of 5 over 5. How can we solve this type of division? Well, to make it a fraction, remember I just can add a number 1 here. And then let's multiply. 1 times 5 is 5, and 1 times square root of 5 is square root of 5. This looks like it's my answer, but it's not actually. Why? Because square root of 5 is in the denominator, and we are not going to let a square root in the denominator. How can we cancel it? Well, we're going to do rationalization. What we're going to do is multiply square root of 5 divided by square root of 5. If you see, I am not changing my equation because square root of 5 divided by square root of 5 is 1, but it's going to help me to rearrange my answer. This answer is 5 square root of 5, and square root of 5 times square root of 5 is square root of 25. What I have is 5 square root of 5 divided by 5. And finally, I can divide 5 divided by 5 is 1. Then cosecant of theta. Cosecant of theta is equals to, and 5 divided by 5 is 1. Then my final answer is square root of 5. Okay, secant of theta is 1 over cosine of theta. And we know this is 1, and cosine of theta is 2 square root of 5 divided by 5. Again, I'm going to rearrange my fraction by 1 over 1 divided by 2 square root of 5 divided by 5, and do the multiplication, this and this, this and this. 1 times 5 is 5 divided by 2 square root of 5. Again, we're going to do rationalization. Square root of 5 divided by square root of 5. 5 square root of 5. 5 times 5 is 25, then the square root of 25 is going to be 5, right? 2 times 5. I can divide 5 divided by 5, which is 1. And my final answer is going to be square root of 5 divided by 2. Then secant of theta is equals to square root of 5 divided by 2. Finally, we have cotangent. Cotangent is 1 divided by tangent. Okay, we have 1 divided by, and tangent is 1/2. What's the first term we found? Okay, rearrange my fraction, 1 over 1 divided by 1 over 2, and then multiply 1 times 2 and 1 times 1. It's 2 over 1, which is 2. Then cotangent of theta is equals to 2. Okay, another fundamental identities we're going to use is sine square of theta plus cosine of square of theta is equals to 1, and tangent square of theta plus 1 is equals to secant square of theta. And the last one, cotangent square of theta plus 1 is equals to cosecant square of theta. This one we already saw them. Tangent of theta, cotangent of theta, secant of theta, cosecant of theta, secant of theta, and cotangent of theta. Now let's try to solve an exercise. Given one value of the trigonometric function, find the values of the remaining ones. Given the tangent of theta is equals to 1/2, theta and acute angle, find the exact value of each of the remaining 5 trigonometric functions of theta. Why it's important to know theta is an acute angle? Because if theta is an acute angle, it means we're in the first quadrant. Then how can I draw a triangle with acute angle? And tangent of theta is equals to 1 over half. Okay, what is tangent? Tangent is opposite divided by adjacent. Then I know my opposite side to theta is going to be 1, and my adjacent side of theta is going to be 2. Then the value that I don't know is my hypotenuse. I can draw something like this, where tangent of theta is 1 over 2, then tan 1 is opposite to theta, and 2 is adjacent to theta, and the value that I don't know is hypotenuse. How can I find it? Well, I can use Pythagoras. This is one way to solve it, using Pythagoras, where c squared is equals to 1 squared plus 2 squared, then c squared is equals to 1 plus 4, or c squared is equals to 5, and c is equals to square root of 5. Now, I just can fill a trigonometric function sine of theta is equals to opposite divided by hypotenuse, 1 over square root of 5. Remember to do rationalization. And the answer will be the square root of 5 over 5. Now cosine of theta is adjacent over hypotenuse, two over square root of 5. Again, we do the rationalization, and the answer will be 2 square root of 5 over 5. Then secant of theta, we can remember what is secant, okay? Secant is 1 over cosine, or we just can flip. If we do 1 over cosine, it's the same as we flip this answer, and we're going to have the same answer. Then just be careful here, because if I choose to flip this fraction, I'm going to have square root of 5 in the denominator again, and I need to do rationalization. Therefore, I can choose this fraction, okay, which is here, this fraction, and just flip this fraction, and my answer is going to be square root of 5 divided by 2. What about cosecant? Cosecant of theta is the same as this. If I choose to flip, okay, the first fraction, then my final answer will be square root of 5 divided by 1, which is square root of 5. And finally, cotangent of theta is equals to 1 over theta. If I flip this fraction, what I'm going to have is 2 over 1, or just 2. Remember what I'm doing, I'm just flipping this fraction, okay? The 2 is going to be instead of the 1. Or, I'm going to do a procedure here, just in case you need to see it. Cosine of theta is equals to 1 over tangent of theta. Remember, we're using the fundamental identity. And this is equals to 1 over 1 divided by 1 over 2. If I multiply 1 times 2, 1 times 1, this is equals to 2 over 1, which is 2. Then, as you can see, it's the same just to flip this fraction. And the same with sine of theta, with cosecant of theta, and the same with cosine of theta and secant of theta.